Welcome back to week 3, video 2. Again, I'm Miss Smith. I hope you watched the first video that I posted introducing what we're going to talk about this week. Now we're going to focus in on the problems that you're going to see from your weekly assignment that is reviewing the domain and range of a square root function. And we just saw in the last video that one of the rules for domain is that the argument, the value under the even root, must be greater than or equal to 0. Okay, we're working with the real number system, so we're not thinking about imaginary solutions at the moment, which is why we have to consider this rule. So what do I mean by argument? I'm talking about here the value under the even root, under that square root x plus 3. That value has to stay positive because are greater than or equal to 0. I cannot take the square root of a negative number while working under the umbrella of the real number system. So what do? Well, I take that value, x plus 3, and I set it greater than or equal to 0. And I start to solve, and I know that x has to be greater than or equal to negative 3. That is my domain. Written in interval notation, it will look like this. X is greater than or equal to negative 3. The range will then be from 0 off to positive infinity. So that range is impacted by the domain. If the smallest value here is negative 3, negative 3 plus 3 is 0. And so then from there, the square root of 0 is 0, which is why my range starts at 0 and it continues going off to positive infinity. All right, let's amp this up a little bit. Example 2. All right, so now there's a lot more going on here. If you connect this to what you did last week with Miss Kulkarni, you could think of this as a composition of function. We've got a quadratic x squared inside of a square root function. Okay, so we have shifts going on here. I can see I'm going to have a horizontal shift with this 9. I'm also going to have a reflection because of this negative. Whatever x squared is, it becomes negative. So what do? Let's think about this. We have our argument, 9 minus x squared. This value needs to stay greater than or equal to 0. So I take it out from under the square root and I set up this inequality. Do some algebra, I subtract the 9 over. Now I've got a negative. I just wanted to remind you of something, that this will have a change in the inequality sign because we're going to multiply through by a negative, or I'm going to distribute a negative. So I get a positive x squared is less than or equal to 9. When we change those signs from being negative to positive, when I multiply through by a negative, that's going to impact that inequality sign. So now I have x squared has to be less than or equal to 9. I'm not done here though. I have to keep solving. I have to undo this quadratic. How do we do that? With a square root. Well, hopefully another alarm goes off in our head that the square root of 9 actually has 2 solutions. That original x value could have been positive 3, or it also could have been negative 3. So once again, notice what happened here. I either have x is less than or equal to 3, sticking with the original sign, but when I apply the negative 3, I have to do x is greater than or equal to negative 3. Now, there's a better way to write this. Think about what this is saying. X is less than or equal to 3, but it's greater than or equal to negative 3. Okay, so it might be better to write this as negative 3 less than or equal to x less than or equal to 3, or skip the inequality notation altogether and write the domain in interval notation from negative 3 to positive 3. Just a reminder, the brackets are inclusive of those values. I can substitute negative 3 into the original function because I'll get 0. The square root of 0 is 0. Now, the range. The range is capped. It goes from 0 to 3. You're probably wondering how I got that. Well, I got a lot of that by just reasoning through this function. Because this constant 9 is out in front and I'm subtracting off x squared, there is going to be a limit on how big and small this can get. Okay, so a better idea is actually to look at Desmos, right? If you don't understand my logic and reasoning on how I got to the range just by looking at the original function, then maybe go to Desmos to become a little bit more familiar with these ideas. So that's what we're going to do right now. I'm going to go to Desmos and I'm just going to open a new blank graph, and I can type this in: y equals the square root of 9 minus x squared. Okay. Now I'm starting to see it, that this is going to get, my domain goes from -3 when it gets smaller and smaller and smaller. My range hits a peak at 0. Think about that. When I input 0 into this function, I get 9 minus 0, which is 9. The square root of 9 is 3. And then I start going into positive numbers, and this output value is going to continue getting smaller and smaller and smaller as I subtract off a larger and larger x squared value. The more you spend time really thinking and diving in and exploring these functions, the better understanding you're going to have of them. Okay, so I have provided the key for you of these functions that you are being asked to try. You'll see the ones I just did are pretty similar to the 4 on section 12 from your summer assignment. But there's 4 problems here I want you to try. These are all on the Google Doc. Try these first before you check my answer key. All right, good luck. There will be one more video where we explore even more exciting functions.